Regions that are assigned to solid continua are automatically assigned the solid type. The physical models such as energy and stress make the appropriate modeling assumptions which govern solids in these regions. Where should we use solid region type? Solid regions in which conductive heat transfer is to be modeled, and solid regions in which stresses are to be modeled. This type is available only for regions containing a solid material. Boundaries are assigned types within their associated continuum. They are used to determine what conditions and values are required. Star CCM Plus recognizes 9 different user selectable boundary types. These are access, flow split outlet, free stream, mass flow inlet, pressure outlet, stagnation inlet, symmetry plane, velocity inlet, and wall. The availability of these boundary types is dependent on the specific models that have been activated within the continuum which is associated with the boundary. We will see these boundary types one by one. The axis boundary represents the axis of a two-dimensional axis-metric region. It is used in conditions like to represent the center line of a pipe or other axis-metric duct. It is available for boundaries of regions containing the axis-metric model. The outlet boundary represents the outlet of a duct. When multiple flow split outlets bound a fluid continuum, we can specify the fraction of the total mass flow through each of the outlet boundaries. The sum of all flow split fractions from all of the flow split outlet boundaries in a simulation must equal to 1. When only one flow split boundary bounds the continuum, it is assumed that all the flow exits through this boundary. The flow split can be specified by ratio or by mass flow rate. The pressure is not specified at a flow split outlet. This boundary type is used in case of incompressible internal flows with multiple outlets for which the flow split between the outlets is specified. Some restrictions are there, like this boundary type should not be used with compressible flows. It cannot exist in the same continuum as pressure, stagnation, and mass flow boundaries or mixing plane interfaces. It is not suitable for outflow boundaries at which recirculation or inflow occurs. Let us see the next boundary type. The free stream boundary represents the boundary of a bubble of fluid surrounding an object flying through space. The free stream boundary condition is based on extrapolation of Riemann invariants under the assumption of irrotational quasi-1D flow in the boundary normal direction. This condition generally applies to external flows when the boundary is placed sufficiently far from the body. Internal flows often have walls immediately next to the flow boundary. These walls can produce boundary layers, vortices, or other multi-dimensional flow structures such that the irrotational quasi-1D flow assumption breaks down. This is applicable in situations like the free stream or far field of an external aerodynamic simulation. If we are using this condition for internal flows, we should position the flow boundary in such a way that the irrotational quasi-1D flow assumption is valid. This type is available only for boundaries of regions in which the ideal gas model is activated. A mass flow inlet boundary represents an inlet for which the mass flow rate is known. It is used when giving inlet to a simulation of compressible internal flows for which the mass flow rate is known. It should be used in combination with pressure outlet boundaries.